Hello there. More fun with quadratics for the 8th grade Algebra 1 students. In this video, we're going to focus on the all-important discriminant. It's the number that's underneath the square root sign in the quadratic formula. Our standard form quadratic function up above, we set the function equal to 0 and solve for x by completing the square. And we get the famous quadratic formula. The x, when we solve this equation, for x, we get two solutions indicated by the plus or minus. This is just a convenient way of writing the two numbers without having to use as much ink. It's really two numbers, one using the plus sign, one using the minus sign. And of course, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Awesome. Once you remember to say that, you should never forget it. Now, these two numbers, one with the plus sign, one with the minus sign, are known by two different names. They're called either the zeros of the equation, the zeros of the function, or the roots of the equation, the roots of the function. Now, to me, and in teaching young people about quadratic functions for the first time, I like the word zeros because it has a meaning. It has a meaning that we can always relate to. One of these numbers with the plus sign, that number will cause the function to be equal to 0. It will cause the y to be 0. And the other number, the one with the minus sign, will do the same thing. They are the values of x that will cause the function or the y to be 0. Now, unfortunately, these two numbers also go by another name. They're called roots, the roots of the function or the roots of the equation. And sometimes those roots are indicated by r sub 1 and r sub 2. And it doesn't matter which is r sub 1 and which is r sub 2. I called r sub 1 the one with the plus. I called r sub 2 the one with the minus, but it could have been the other way. So you've got these two zeros or roots which are given to you by the quadratic equation. The roots or zeros of a quadratic function are the two numbers negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're focusing in this video on the number that's under the square root sign, the b squared minus 4ac. That is known as the discriminant because it discriminates as to how the graph of the function crosses the x-axis. I'm going to use a capital D to stand for discriminant. Saves a little ink, a little time, rather than writing out b squared minus 4ac. So capital D for the discriminant. When the discriminant is positive, when it's greater than 0, you don't have any problem with this square root. It's a real number. The square root of a positive number is real. And of course, we use the positive version and the negative version of that square root. Now, the b squared minus 4ac may or may not be a perfect square. If it's a perfect square, then if, let's say, b squared minus 4ac is 16, then the square root of 16 is 4, and we'd have plus or minus 4. But the discriminant could be 20, in which case the square root of 20 is not a whole number. It's irrational, but it's real because the 20 is positive. So when the discriminant is greater than 0 or positive, there will be two real roots, one with a plus sign, one with a minus sign. Two real numbers that will make the function equal to 0. Two real x's that will make the graph of the function cross the x-axis. When the function is equal to 0, the graph of the function is on the x-axis. And there are three possibilities. There can be two places where the graph crosses the x-axis. The next case is where the graph of the function crosses the x-axis at only one place. If the discriminant is 0, then you come back up here and you look plus or minus the square root of 0. Well, the square root of 0 is 0, and plus or minus 0 is the same thing, right? If you add 0 to the negative b or subtract 0 from the negative b, it's still going to be negative b over the 2a. So when the discriminant is 0, we call it a double root. The reason we call that a double root is because of the fundamental theorem of algebra. The fundamental theorem of algebra says that an equation of degree n will have n solutions within the complex numbers. The complex numbers are the numbers that include reals and non-reals. Our quadratic is, of course, of degree 2. The highest exponent is 2. So according to the fundamental theorem of algebra, a quadratic equation, which has degree 2, has to have two solutions within the complex numbers. There has to be two solutions to this equation, and that's indicated by the plus or minus. Now, when the discriminant is 0, it's really only one number, but you kind of get to it two ways, one through the plus sign, one through the minus sign. So it's called a double root, and that allows the fundamental theorem of algebra to still apply. We pretend it's two different numbers, even though it's only one. The discriminant equal to 0, a real double root, and the vertex will be on the x-axis. And that brings us to the third case, where the discriminant is negative. D is less than 0. Now, as you know, the square root of a negative number is not real. So whether you've got the plus sign or the minus sign in front of it, if the discriminant is negative, both of those roots or both of those solutions are not real. They're considered roots. They're considered solutions to the equation because, as you'll learn as you go forward, there's a bigger collection of numbers than the real numbers, known as the complex numbers. When the discriminant is negative, there are still two numbers, one with a plus sign, one with a minus sign. It's just that they're not real. Now, because they're not real, these values of x that make the function equal to 0, remember that the x-axis is a real number line. And when the discriminant is negative, the zeros of the function are not real. They're not on the x-axis. There's no number on the x-axis when the discriminant is less than 0. There's no number on the x-axis that will make the function equal to 0. So the graph will not cross the x-axis. When the discriminant is negative, there are two non-real roots, and the graph does not cross the x-axis. So maybe you want to pause. Hopefully you can see that whole board there. Pause the video until you've got all of that. It's in your textbook, but here it is. And we're going to close out this video by looking at some graphs. We have to consider three cases. I've just reminded you up here of what the discriminant is, the b squared minus 4ac, the number that's underneath the square root sign in the quadratic formula. We're going to consider the case where d is greater than 0, and then where d is equal to 0, and finally where d is less than 0. Now, for each of these cases, I'm going to draw two graphs, but I want you to realize that I'm only really interested in where they cross the x-axis. I'm not particularly interested in where they are right to left. I'm not interested in how wide or narrow they are. They could be wider, they could be narrower, depending on the a, which we looked at in a video. But remember, in a video we said that the if the a is positive, the parabola opens up. If the a is negative, it opens down. So I want to look at those two situations for each of the three situations. One where the graph opens up and one where it opens down. So if the discriminant is greater than 0, you could have a graph that looks like this. And notice that it opens up, so the A is positive, and the vertex is below the x-axis. Just think about this. It's just exactly what your eyes tell you. If the vertex is below the x-axis and the parabola opens up, then the parabola will cross the x-axis in two places. And this situation happens when the discriminant is greater than 0, because you get those two real roots. Whatever this value of x is one of the roots or zeros, and this value of x is also. In this particular drawing, this particular graph, both of the zeros are negative real numbers. Okay? But you could also have this situation. You could have, and by the way, in this one here, on the left that I just drew, the A is greater than 0. Over here, the A is less than 0. This goes back to the other video. When A is less than 0, the parabola opens down. And if the discriminant is greater than 0, then there are two real zeros, two real roots. So in this graph here, we've got the vertex above the x-axis with the parabola opening down. That causes the graph to cross the x-axis at those 2 points. These both happen to be positive. Again, either of these graphs could be anywhere left to right, but the way I drew them, this is a positive real x, and this is another positive real x. Two real roots, two real zeros of the function. If the discriminant is equal to 0, remember, as we said earlier, if the discriminant is 0, you have the square root of 0, which is 0, and then you've got the plus or minus in front of it. Plus 0 and minus 0 is the same thing. So what has to happen graphically here is there's one real 0 or one real root, but we call it double just so that the fundamental theorem of algebra still holds. Well, you could have this situation. You could have a parabola that opens up and the vertex is sitting on the x-axis right there. Now this 0 happens to be positive. The value of x that makes this function equal to 0 happens to be this positive value of x, this real value of x. This is the vertex of the parabola. It is sitting on the x-axis because the discriminant is 0. Those two things always go together. You could also have a parabola that opens down, with the vertex sitting on the x-axis. This is also a case where the discriminant is equal to 0. By the way, just to review with the A, this is a case where A is greater than 0. The parabola opening up means that the A is greater than 0, and the parabola opening down over here means that the A is less than 0. So this is the second situation where the discriminant is 0. And finally, what if the discriminant is less than 0 or negative? That would give us a negative number inside the square root sign in the quadratic formula. Well, the square root of a negative number is not real. So when the discriminant is less than 0, the function has no real roots or real zeros. It does have, because of the fundamental theorem of algebra, it does have two roots or two solutions that cause the function to equal 0, but those two roots, those two solutions are not real numbers. So what happens graphically when the discriminant is negative? Well, one of two situations. One situation is this, and again, this parabola is opening up, so the A is greater than 0. But what's going on here graphically? The vertex is above the x-axis, and the parabola opens up. It'll never cross the x-axis. This graph will never cross the x-axis. That goes along with the fact that the discriminant is negative. And the other situation, you might have guessed, the parabola could open down. The a could be negative. If the a is negative, the parabola opens down. And I've sketched a parabola here where the vertex is below the x-axis and the parabola opens down. This parabola will never cross the x-axis. It's one of these two situations that happens when the discriminant is negative. So I can't resist this little pun at the end. Be very discriminating in your learning of math. Learn the different situations, and in this case, the discriminant. It's very important to the study of quadratic functions. Bye-bye for now.